Okay, the next problem on the list, we let this be S of n. 1, we want to show S of 1 is true. That is, either plug 1 in there, you get 1 times 3, and plug a 1 in there. 1 times 1 plus 1 times 2 plus 7 over 6. 3 equals 1 times 2 times 4 times 9. Right? 3 equal 18 over 6. 3 equal, got it. 2. Suppose the statement is true for natural number k. That is 1 times 3. Let me color code that. Let's use green. 1 times 3 plus 2 times 4 plus 3 times 5 plus k into k plus 2 equals k into k plus 1 into 2k plus 7 all over 6. Then S of k plus 1 would be 1 times 3 plus 2 times 4 plus 3 times 5, the first k terms, and the next term. The next term is simply, there is a sub k, replace k by k plus 1, and the right side, replace each of those k by k plus 1. Okay, you know what? I have plenty of space. I'm gonna move all of that down there, and I'm gonna really expand it out with these. I don't want to squish anything. There, no need to squish anything out. So the right side we said was, replace that k by k plus 1 into k plus 1 plus 1 into 2 into k plus 1 plus 7 all over 6. I'm allowed one step on the right hand side, and never, if you FOIL the right side, then pretty much you're not gonna get anything. So be careful. When I took the class ages ago, 2 plus 7, when I took the class back in the days, we couldn't even do that step. We have to get it back to look exactly like that. I'm saving some of that drama. It is important, but it's okay. I allow one step because you know me, easygoing and all. Well, look, the left side, I made an assumption that this green part is this. Make the replacement. K into k plus 1 into 2k plus 7 over 6 plus k plus 1 into k plus 3. Now here you gotta be careful. If you FOIL, it's very hard to do. Instead, I'm gonna factor k plus 1 out of both of those. If I take k plus 1 out of that, what's left? K into 2k plus 7 over 6 plus, if I factor k plus 1 out of that, I'm on the right track because there's a k plus 1 right there. That's very good. So let me continue on. That is k plus 1 times 2k squared plus 7k plus 6k plus 18 all over 6. K plus 1 times all over 6. That's 2k squared plus 13k plus 18. K plus 1. Remember identities? I know what that's gonna be. Make sure it factors that way though. Make sure you didn't make a mistake and you're forcing it to be. So 2k and k. And if I put a 9 there and a 2 there, does that work? That's 2k squared plus 4 plus 9, that's 14 plus 18. Perfect, got it, done. Either this or the other symbol. Now what? And if you don't write the symbol, I'm going to let it slide. But now what? You have to restate the original statement. 1 times 3. You're going to restate the original state. 1 times 3 plus 2 times 4. 1 times 3 plus 2 times 4 plus 3 times 5 plus, and what was it again? I keep on forgetting. It was n into n plus 2 equals, it was n into n plus 1 into 2n plus 7 all over 6. And you're done. So you have to show me everything I'm showing you. Normally on your homework, I look for completeness. But in this case, I'm going to look whether you got everything right or wrong, and I am going to grade that part. Just saying. Alright, the next problem, the same deal. Let this be S of n, 1, S of 1. Take the first term, or plug 1 in there. 3 to the 0 is 1. That's 1 half into 3 minus 1. 1 equal half of 2, 1 equal 1. That checks. This one I think I could put them side by side. Step number 2. Suppose the statement is true for natural number k. That is, suppose that 1 plus 3 plus 3 squared plus 3 cubed plus 3 to the k minus 1 equal 1 half into 3 to the k minus 1. Then, for s of k plus 1, 1 plus 3 plus 3 squared plus 3 cubed plus 3 to the k minus 1 plus, what's the next term? Replace k by k plus 1 equals 1 half, throw a k plus 1 in there. There it is. My assumption is that this sum equal that. The purple part equals 1 half 3 to the k minus 1 plus 3 to the k. Now here, this is going to be 1 half 3 to the k minus 1 half plus 3 to the k. Now, something that I'm going to play with really quick. If I take those two, if I factor 3 to the k out of that, what would be left? A 1 half plus a 1, right? So if I had half x plus x, if you take x out, isn't that 1 half plus 1? And what would that be? That is 3k, get a common denominator. And now I'm going to ask you a simple question. What is a to the n times a to the m? Isn't that a to the n plus m? When I, oh, and don't forget the minus 1 half. And if I multiply 3 to the k times 3 to the 1, isn't that 3 to the k plus 1? You add the powers. And if I factor a 1 half out of those, wouldn't that be 3 to the k plus 1 minus 1, which is exactly what I want. So I have to get that right side identically. And then what? I relist the original. Therefore, 1 plus 3 plus 3 squared plus 3 to the k, was it plus 1? Minus 1. 3 to the n minus 1. I'm sorry. 3 to the n minus 1 equals 1 half into 3 to the n minus And that would be it. Now, in case you were wondering what this means, look, just for you to make sure that you see what they're doing. If I take 1 plus 3 plus 3 squared plus 3 to the 10th, how do you get a 10 out of that? Wouldn't that be n equal 11? If you put n equal 11 in there, 11 minus 1 is 10. That says that's 1/2 times 3 to the 10 minus 1. Instead of adding those 10 terms, plug this in your calculator, that gives you that answer. Instead of adding the first 100 terms, I could plug in 100 in there and figure out what that sum equals. So this is very useful and very powerful. If you like this stuff more, take combinatorics. They play with that a lot. And how about this right here? Again, we're going to let this be S of n. I don't like this only because it's the first official proof. I like this because it rebuilds some of your algebra tricks. So S sub 1, 1 over 1 times 3 equals, and on the right hand side, 1 over 2 times 1 plus 1, 1/3 equal 1/3, it checks. Now what? Suppose the statement is true for natural number k. That is, suppose that S sub k is true basically. 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 plus 1 over 2k minus 1 into 2k plus 1 equals k over 2k plus 1. Very simple. Then what? Then we're going to go for the next, for k plus S of k plus 1, that is 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 plus 1 over 2k minus 1 into 2k plus 1 plus one more term. What's the next term? Replace the k by k plus 1. 2 into k plus 1 minus 1 and 2 into k plus 1 plus 1. And that's going to equal, put a k plus 1 in there and put a k plus 1 in there. You're allowed to simplify the right side, that part. That is 2k plus 2 plus 1 is 3. Now, I made an assumption. Is that going to always be the case? Of course that's going to always be the case. I'm going to take k over 2k plus 1 plus 1 over, this is 2k plus 2 minus 1 is 1 times 2k plus 2 plus 1 is 3. If I factor out, oh boy, if I factor out of those 1 over 2k plus 1, what would be left out of this piece? Just a k. And if I factor this piece out, 1 over 2k plus 3, now what? I know exactly what to do. This piece, I'm going to leave it alone, and I'm going to work this out. The common denominator is 2k plus 3. Multiply top and bottom by that. Isn't that 2k squared plus 3k plus 1? Wouldn't that be 2k plus 1 into k plus 1? 2k squared plus 2 plus 1 is 3 plus 1. Wouldn't this cancel with that? And what are you left with? K plus 1 over 2k plus 3. Does that match? Right there. Therefore, 1 over 3 times 5 plus 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 plus 1 over 2n minus 1 into 2n plus 1 equals n over 2n plus 1. And that's the official proof, and you're done. And that's pretty much it for this section.